So this video is for more complex absolute value equations. If you have not watched the previous one, I would suggest you start with absolute value equations before you come to this one. All right, so we are going to start with 2x plus 5 equals 3x. We're going to approach this. Notice there's a variable out here, so maybe that's going to be like, oh my gosh, don't worry about it. Treat it like we did the other ones. You're going to write the two equations. 2x plus 5 can equal a positive 3x. I can have a positive 3x in there. Or 2x plus 5 can equal negative 3x. So don't let the variable out there scare you away. Now we solve for x. Subtract 2x. 5 equals x. Subtract 2x. 5 equals negative 5x. Divide by negative 5. Divide by negative 5. X equals negative 1. So first scenario, don't let that x out there scare you away. It's the same as before. You write one with the positive, one with the negative, and you solve. Another way they can make them a little scarier is if you had like x plus 4 minus 16 equals 9. People get so tempted. They're like, all right, it's an absolute value equation. I know how to handle it. I'm going to write the two problems. Just like we did here, we wrote the two problems. Notice here, the absolute value was isolated by itself. In this scenario, we have that 16 there, so it's not isolated by itself. Before we write the two equations, we need to isolate it. Add the 16, add the 16. If we add 16 to both sides, we end up with x plus 4 equals 25. Now do you see how the absolute value is the only thing over here? That's when you can write the two equations. Don't go crazy and write the two equations too early. It'll cause you trouble. So my first equation, x plus 4 equals positive 25. And the second one, x plus 4 equals negative 25. This looks a lot like the basic ones now, right? So then we minus the 4, x equals 21, minus the 4, x equals negative 29. Well, let's try another one. What if we had 2x plus 10 divided by 3 minus, we can make these look scary, 5 equals, I don't know, just 4 to keep numbers small. Making it up as we go. Notice this whole thing here is getting divided by 3. So the first thing I want to do, I want to add the 5. Get that 5 out of the way. So then we get 2x plus 10, still being divided by 3, equals 9. Now, if this thing's being divided by 3, what undoes dividing by 3? Multiplying by 3. And then cancel. That was not in the absolute value bars. If it was in the absolute value bars, we would approach this differently. But since the bars were only around the top part here, the numerator, we're going to get rid of it. So then we get 2x plus 10 equals 27. Oh, absolute value bars. Now at this point, we write our two equations. 2x plus 10 equals positive 27. 2x plus 10 equals negative 27. So the idea is get the absolute value bars isolated by themselves. What if we had, for example, 5 times the absolute value of x plus 1 equals 6, let's just say. 60. I'll make it prettier. So it's 5 times. This is not considered isolated yet. You need to get rid of the 5. So you're going to divide it by 5. Divide it by 5. So you end up with x plus 1 equals 12. Now it's isolated. We can write our two equations. X plus 1 equals positive 12. X plus 1 equals negative 12. See the two equations. Subtract the 1. X equals 11. Subtract the 1. X equals negative